The definition of even and odd functions, for those of you going into 212, not biggie, we don't really care. For those of you going into the engineering calculus, that would be the 220, and into trigonometry, even and odd functions play a role in what you do because of the trigonometric functions and some of the other stuff that you're going to do. When I think of an even function or an odd function, I think of things like x cubed and x squared because of even powers. But technically speaking, if a function is even, there's a test for it that says if it's even, if you plug in minus x into the original function, it ends up being the original function. So in other words, it kills the negative. So that if you think of x squared, if you would put a minus x into x, and then you'd square the whole thing, you'd end up with x squared. So it's going to kill the negative, and that's what makes the function, the function even. So if I were going to look at this, I'd look at, this is the original, and I don't like that pen. Now I'm going to look at f of minus x, and I'll say I'm going to put in minus x for all the x's. And if I put in minus x for all the x's, whoops, this is to the fourth power, minus x for all the x's, and I come out with the original that says the function is even. So this would be 2 times minus x to the fourth. Well, that's an even power. That's going to quash the negative. So this is x to the fourth minus a minus x squared. That's an even power. That's going to quash the negative. And you notice it's the same. So this guy is even. So f of x is even. And you think if all the powers are even powers, it's going to be an even function. So if all the powers are even powers, it's going to be an even function. Now odd, I think of x cubed as being odd. Now what does the odd function do? It does not kill the minus sign. As a matter of fact, it turns the function into the opposite of the original. So if you had everything with odd powers, of course, it would be an odd function, and then, which is what this guy is. So it says, put minus x in for x. What you want to have as a result is the opposite of the original function. So this is the opposite of the original. So there will be original function with minus 1 out in front of the whole thing. So if I look at f of minus x, this would be 3 times minus x to the fifth plus 5 times minus x, which turns into the opposite of 3 times x to the fifth, because x to the fifth is minus x to the fifth, minus 5x. This turns into, it has a greatest common factor of negative 1, 3x to the fifth plus 5x. And if you look at it, it is minus 1, and this right here is the original function. So it's minus 1 times the original. So this is an example of an odd function. Now the question is this guy odd? Well, what would you look at? F of minus x. It's going to be the opposite of the original. which is minus x over minus x squared minus 1, which is minus x over, minus x, the quantity squared, is just x squared minus 1. And if you notice, this can be written as minus 1 times x divided by x squared minus 1. And what do I notice that it is? Minus 1 times the original, right? So you could say that if I were doing this as a mathematical person, then I would say that this is minus 1 times f of x. So I've got f of minus x equal minus f of x. But he is also odd. I don't know, what would you rather be, odd or even? Maybe you don't want to be called odd. Maybe you are odd. You guys aren't awake yet. I'm not either, so. Our first theorem, woohoo! From a graphical point of view, theorem. A function is even if it is symmetric with respect to the y-axis. That should make sense, right? Y-axis symmetry. That's x. This is minus x. And odd if it's symmetric with respect to the origin. And I used x squared and x cubed. Something that is going to be fan faves. Personally, I don't think about it that way. However I do think about it. I just put in minus x and see what happens. Even or odd. This is the biggie for us. Even more than even or odd. The definition of increasing. Now this is the mathematical definition. It says a function is increasing on an open interval I. And that open interval could be minus infinity, infinity. It could be 1, 5, 1, 12. If for every choice of x1 and x2 in the interval with x1 smaller than x2, we have f of x1 smaller than f of x2. Huh? Well, what is it saying? I'm picking two x values in the interval. And I'm moving from smallest to largest, left to right. So I said I'm going from left to right. And if the x's are going from left to right, I notice the y values, that the first y value is smaller than the second y value. Now what's that saying? The y values, VA, are doing what? If the y1 is smaller than y2, increasing means they're getting larger. Now let's make this easy. All this says is this. I pick two x values. I'm going to go from left to right, and my pen should be going in what direction? if I'm increasing?
To the right.
If I'm going from left to right, what should my pen be doing as I'm drawing the graph? Going up. Woohoo, increasing. Should be going up. That's increasing. Now the question is, what is increasing? Y is increasing for X. X is always in control because he's the domain. Y is the guy who's going up. Anytime I am running parallel to the y-axis, this kind of movement, these are y values. There's underlying x values, but these are y values. So y is getting bigger as x gets bigger. X gets bigger, what's happening to y? Oh, it's getting bigger, it's increasing. So as x gets bigger, what happens to y? One of three things will happen to y. Y gets bigger, y stays the same, y gets smaller as x gets bigger. Decreasing. A function f is decreasing on an open interval I, decreasing on open interval I. See, I don't care what's happening at the endpoints. I only care what's happening on the inside. If for every choice of x1 and x2 in I with x1 less than x2, then f of x1 is greater than f of x2. This again is saying left to right. This says y1 is bigger than y2. Now that means the y values are getting what? Penn tells the story. That says, again, I have x1, x2. I pick my point, and my y values are going down. This says y is decreasing for x. And as I'm doing applications, that can become